review just in case you needed help with your steps. Okay, so you can take notes or you can just watch it, but it's going to review the different concepts that we've been dealing with. So one of the concepts that we've been dealing with is combining like terms, justifying our steps, that means knowing our properties, as well as solving for x. So we're going to look at an equation that does all of those things combined. So this example is 5x minus 4x plus 5 equals 25 minus 8. So before I do anything and solve for x, I have to say, all right, I have to combine my like terms first. So I can see that my 5x and my 4x are the same, but that I don't subtract in algebra. I add the opposite. So I'm going to change all of these guys, and now I'm going to combine these like terms. So 5x plus a negative 4x gives me a 1x. You can write the 1. You don't have to write the 1. Now I've done that step. I'm going to write everything else. Plus 5 equals 25 plus negative 8. Now I can see that I can combine these guys, but I cannot combine these ones. X and 5 are not alike. They are not the same. And x looks like this, and there are 5 little pieces. Therefore, they're not the same. They cannot be combined. So I have to leave them alone. X plus 5 equals, but I have 25 and I have negative 8. I can combine those. So I have a positive and a negative, which means I'm really subtracting. So when I subtract, I get 15 minus 8 is 7, and 1 minus 0 is 1. So I put my 17 here. And it's a positive because this number is positive, and it's the biggest absolute value. It's the appearing bigger number. Okay? Now I have x plus 5 equals 17. In order to solve this, I have to get my x alone. So I want to cover my x and say, oh, look, there's that positive 5 that has to be removed. So I'm going to add the opposite, and the opposite of 5 is negative 5. If I do it to one side, I have to do it to the other side. I'm left with x, because a 5 and a negative 5 make a 0, and 17 and a negative 5. One is positive, one is negative, so over here I'm going to do my subtraction. 7 minus 5 is 2. 1 minus 0 is 1. So I'm left with 12, and it's a positive 12 because this one is bigger. So my answer is x equals 12. And of course, I have to check my work. So I've used my space over off to the right, so I'm going to do my check below. I'm going to start with my original problem, because I always start with my original problem when I'm dealing with a check. I'm going to recombine those like terms again and say that I have x plus 5 equals 25 plus a negative 8. And now I'm going to plug in my 12. I could have plugged it in here. It just makes much bigger numbers, so if I combine them first, it's a little bit easier. So I'm going to take my 12 and plug it in for x and write my problem. Okay, I did 25 plus a negative 8 once, and I got 17. So I'm going to put it there. And 12 plus 5 is 17. And 17 equals 17. So that means I did my problem correctly, and 12 really is the answer for x. Okay, I'm going to do another problem. My next example is w minus 1/3 equals 2/3. Now, I never subtract in algebra. I add the opposite. In order to solve for w, I have to get my w all alone. So I want to put my finger on my w and say, oh look, this is the number that has to be moved. I want to make it a 0. I want it to be w plus 0, or w all by itself. So in order to get that, I have to add the opposite. And the opposite of negative 1/3 is positive 1/3. If I do it to one side, I have to do it to the other side. Now I have a negative 1/3 plus a positive 1/3. That makes a 0 pair. They make a 0. So I'm left with a w on the left, and then I have to do the math on the right. 2/3 plus 1/3. Well, the denominators are the same, so I can just add the numerators. 2 plus 1 is 3. And another way to write 3/3, because that's not in simplified form, is as a 1 whole. So W equals 1 whole. So I'm going to check my work. And I'm going to start with my original equation. And now I'm going to plug in my value for W, which is a 1, and write the rest of my problem. Now, in order to add these guys, my denominators have to be the same. So I have to make this 1 have a 3 denominator. So I'm going to say I want it to have a 3 denominator, and I'm going to write everything else. Now, if I go from a 1 to a 3, I've multiplied by 3. So 1 times 3 is 3. And I have 3/3 plus 1/3 equals 2/3. So 3/3 plus negative 1/3 you can actually do because the denominators are the same. And so you subtract 3 plus a negative 1 is really 3 minus 1, which is a 2. And 2/3 equals 2/3. So that means I did my problem correctly, and W equals 1 is really the answer. Now, sometimes when we're solving for a variable, we have a fraction. So we might have something that looks like, I'm searching for a sample. We might have something that looks like 26 equals negative 2D. In this case, when I cover my D, there's no numbers that have to be added or subtracted away. But I still have a number there, which means that I have negative 2D's. I have 2D's, and they're both negative. And in math, we usually shade them or color them a different color. So I have 2 negative D's. I don't want 2 negative D's. I want 1 positive D. So how do I get D to become a 1 positive D? Well, this is really multiplication. Negative 2 times D. And in math, we say if you want to get rid of the negative 2, you want to multiply by the inverse. The inverse is a reciprocal. Negative 2's reciprocal is negative 1/2. Okay, the reciprocal is 1/2. And then because I want the negative to go away as well, I can take the negative here as well. So I'm saying negative 2D times negative 1/2. Now this can also look like, if you have negative 2D, you could also say I'm dividing by negative 2. Negative 2 divided by negative 2 is a 1. And so I'm left with 1D, which is what I wanted. We usually just write it as the letter D. Okay? But I want you to see that dividing by a negative 2 is the same thing as multiplying by a negative 1/2. And that's going to become really important in the next problem that I show you. So I'm going to do it this way. I'm going to say I'm multiplying by the reciprocal, which is the it's the multiplicative inverse property. If I multiply by negative 1/2 on one side, I have to multiply by negative 1/2 on the other. So negative 2 divided by a 2 is 1. And you have a negative divided by a negative is a positive. So you're left with a positive D. And now you have a 26 divided by a 2. So I can say 26 is really 2 times 13 and cross out my 2's for an equivalent form of 1. And now you have negative 1 times 13 is negative 13. And this is my answer. I'm going to show you one more problem. The next example that I'm going to give you is C divided by 7 equals negative 1.8. So in order to solve this problem, I need 1C, but right now I have a 1/7 of a C. I have C divided into 7 pieces. I don't want that. The other way that we can write C over 7 is really C times 1/7. This thing and this thing are equal. So if we know that, we can say, hey, we want to get rid of the 1/7. And in order to get rid of it, when it's being multiplied by that C, I have to multiply by the reciprocal, the multiplicative inverse property. So the reciprocal would be 7 over 1. And if I multiply by 7 over 1 on one side, I do it to the other side. This becomes canceled out, and you're left with a C. And now you have to say that I have 1.8 negative times 7. So over here, I have to do the math. And 7 times 8 is 56. Carry my 5. 7 times 1 is 7 plus 5 is 12. And I have one decimal place, so I get 12.6. And a negative times a positive is a negative. So my answer is C equals negative 12.6.